From an early age, I found that I had a fair amount of mechanical intellect just from playing with Legos and Kinects. From the crazy designs that I used to come up with, it was pretty obvious to me that I needed to go into something with design.
When I was a kid, I raised birds, and I also liked everything mechanical. Got a car from my grandpa, and I took it completely apart and put it back together again. Here's the HUD camera prototype. We want to see if it fits. That's way too big. This is the HUD right there, so yeah, we don't have much room at all. I've always liked mechanical things, and I think engineering was just the perfect fit for me. I think I was born to do this.
I went to air shows when I was a kid where you could fly in the plane for a penny a pound, so it was a pretty good deal when you're little. And I think at that point in time, I always thought I'd be working on aircraft in the future. The Aero-Mechanical design group integrates hardware and systems into typical military and commercial aircraft to make them flight research vehicles.
A common task for the design group is creating and designing a bracket or a fixture to hold a research instrument on one of our airplanes.
You might have a new probe that goes on an airplane and they want to fly it on an F-15. We'll help build the probe or tell them where they can put it or tell them what their limits are and what we can do for them.
Generally, it'll be an instrument that measures something in the air or some sort of camera system, that kind of thing, as far as taking what somebody already did and integrated it into the aircraft.
We are the middleman in coming up with the data for research projects. A lot of the design work that we do has to account for the environment that airplanes operate in. That might include climate, where it gets very cold and very hot, and being able to function well in the airstream if something is mounted on the outside of the airplane. Also has to account for precipitation and corrosive effects of the environment to make sure that the airworthiness of the part isn't compromised during its mission. For example, if a sensor is being mounted to the skin of a wing, we might have to design or change the shape of the wing to allow for proper airflow around it during flight. This is our Gulfstream aircraft, and right now we're testing a morphing flap. Basically, this flap flexes instead of actuates downward. My job in this project was to facilitate the installation of the flap into the wing. Some of those roles include creating drawings for structural components that attach the two together and providing up-to-date inspections, verifying that the flap surfaces align well with the predicted flap data. Right now I'm going to bring in the reference model for the right wing that the scan will be compared to. And you can see that we have a really good match. Basically the green shows that the two surfaces are aligned very well. The blue surface is showing that the surface is slightly below where we predicted, and red slightly above. It's important for us to know that the two surfaces are aligned well because previous predictions were based off of an idealized model. If the idealized model tells us that the plane is safe. However, if we go back and we find out that the actual airplane is not joining up well with that idealized model, our predictions for flight safety are no longer valid.
As long as it can stand there, like I say, I don't think we need to worry about when it's done or anything. If we put the cone on and then just leave it, can we leave it for a while? We'll come up with a design and then we'll oftentimes run it by the crew and decide if it's okay with them as to where we put it and how it's going to be mounted, and then we'll have structures people look at it. Knock, knock.
Yes.
We'll take the preliminary drawings down to the shop, either sheet metal or the machine shop, have them look at it, see how manufacturable it is. Is there a lot of difference between manufacturability as far as aluminum versus stainless?
Absolutely.
On these parts?
Oh yeah.
Aluminum would give us a good trial, maybe.
That's fine. We could always come back and make another one.
Right.
Are you redrawing this now then, or are you making some modifications?
Oh, I'm just making the fixes.
Okay.
Yeah.
All right.
All right.
And then when you do, you come bring it back over.
Yeah, I will.
So we can look it over again.
Right. Sounds good.
Okay.
Thank you, sir.
All righty.
All right. This is the inside of that nose cone that we're looking to put on. We've gotten the nominal sizes of the equipment from instrumentation, and we put that on a pallet. We only have so much real estate, so we have to just make sure that everything is adequately spaced. We know how big it is. And we're just taking those components and doing just making sure we have enough room for everything.
Sophia, we added all kinds of things to the aircraft, inside and outside. Pretty extensive modifications on that aircraft. We had to install large thermal insulation blankets and foam insulation into the telescope cavity. We added maintenance stairways and scaffolding into the cavity, added all the racks.
After the part's been installed and it's been signed off, we may be called back to do revisions if the project requirements change while the part's being used. For example, we found that the cameras on the back of the aircraft were getting way too cold. Because they were getting cold, they were distorting the lens and thus distorting the picture that people were seeing in the control room. I'll be taking a look at that and trying to find out a way to prevent the cameras from getting too cold so we don't have this problem in the future.
The HD camera goes to minus 22 degrees. We're at 40,000.
I think what's happening is you've got an aluminum body which contracts a lot with cold, and it's just crushing the lens. So it's not even the polycarbonate that's the problem, it's the body. If we take the case that you're talking about and we cut it in such a way that we fit it into, like, take out this RTV, make this hole a little bit bigger, and then glue the case to the panel so that the camera is still not really touching the case.
Well, that sounds good. Okay, we'll do that.
I like designing because I get to try to be imaginative, try to figure out things, develop my own ideas on how to do something. It's interesting to me.
You never know what good idea is going to turn into something great.
One of the coolest things about my job is I get to work on nearly all the airplanes at the center. On one particular day, I might be working on a remote control airplane, a glider, and a fighter aircraft. On another, it might be a 747 or small propellered airplane. What keeps the job interesting is the great amount of variety of design tasks that are always required. We provide support in many engineering areas, kind of like handymen for the engineering world.
I think a lot of people think that engineering isn't as creative as art or something, but there's a lot of different things you can do with the facts you have, and that's what I like about engineering. We're doing good science and we're trying to make the world a better place. To get paid, to have fun, to do things like that, to do good things and feel good about it, I can't think of a better combination, really.